Hi, welcome to this Tetration video series session module on exactly why are we here today. My name is Tim and I'm joined by Remi over here, and without further ado, let's get started. Take a look at this quote. It takes 20 years to build a reputation and a few minutes of cyber incident to ruin it. That's the quote from the CISO of OVH. I'm going to pronounce his name as Stefan Napo. Remi's probably going to say I butchered that.
Of course, Tim.
But it's my best attempt. And this quote is in the mind of every single CISO out there in the world. Many of them are waking up in the middle of the night wondering, is it going to be me next? Is my organization at risk? And the reality is, unfortunately, yes. Yes, you are at risk. Look at this, Remi. It's just a smorgasbord of different breaches that we've had to look at in the last couple of years. And looking at them, they are by no means small breaches, are they?
No, they seem to be pretty large company. I mean, when I see the names down there, and I'm guessing that's a subset.
I mean, this is just a tiny sample of what we've seen.
So they seem to be pretty big names though, right? I mean, I don't think they can do things wrong at that level, can they?
So that's a very interesting point. And the reality is they aren't doing anything wrong per se. All of these organizations had incredibly good security portfolios already deployed into their environment. They were using top-of-the-line firewalls, they had IPS, IDS, they had a fantastic security team that was watching the logs, looking at the connections, monitoring what's going on. Yet, unfortunately, they all still happened to be breached. And not only were they breached, but those actors were able to get in there and poke around for a very long time.
I'm a bit confused. You're telling me that they had everything needed, everything was good, everything was ready, they had the rockstar teams and so on. So why did they get breached then?
Well, what's happened, unfortunately for them, is that quite literally the earth has shifted under their feet. The applications, the workloads, the data that they are trying to protect, it's changed. It's changing faster and faster as we go through time. And the security needs are changing along with that. So let's take a look exactly what I mean by that particular statement. We were looking at some research earlier. It wasn't research about bears, it was about security. And what do you think this 19 minutes means?
So, I mean, before you talked about bears, I thought that it was the time to shave the bear.
I mean, if you can pin down a bear for 19 minutes and try shave it, you'd be pretty good. And it's also not how long it takes me to do my hair in the morning.
Not, no.
Definitely not 19 minutes. So actually what that particular statistic is about is how long it takes a sophisticated state-level actor to go from initial breach to a complete foothold inside a customer environment. 19 minutes.
That seems pretty short. I mean, 90 minutes, how long have we been talking for? Like maybe 5 minutes or so already?
Yeah. If that happened in the middle of the night, do you think you could react within 19 minutes?
I don't get out of bed in less than 19 minutes for sure.
Yeah, I know that. I know that for sure. So once they've got inside the network, what happens next? Well, just like this very lovely bear over here, on average they get about 100 days to swim around in a customer environment before someone actually realizes that they're in there.
100 days?
Yeah.
Man, I already get the smell of the bear like for 100 days in the water now.
Yeah, imagine what you could do with 100 days in the environment. This bear is going to be a very happy bear.
Oh yeah, definitely. So you're saying that the guys have take 19 minutes to manage to find their way in to an environment, and once they're in, on average, we're saying that they have 100 days to kind of just roam around?
Pretty much.
Wow.
I mean, it doesn't sound very fantastic for a company, does it? And you can understand why a huge amount of organizations are worried at this point. So let's take a look about some of the drivers behind this change in what we need to do to secure our applications and data. One of the things that we've noticed that's changing for a lot of our customers is the fact that the perimeter that they used to deal with is pretty much being eroded every day. They used to be familiar with this old perimeter, which was where there was a soft, chewy center and a very crunchy outside. That's one of the ways that people sometimes describe it. Typically that was possible because a customer owned the data center, they owned the servers, and they owned the applications. So it was very easy to control access in and out of that environment.
So just to be clear, like when you show that, and you're talking about the soft GUI center and so on, that's for you the actual physical data center?
Exactly. This is when you owned the data center and you could truly secure it with physical appliances. You could even put a lock and key on the front of the data center. I know. I know. But as you can see from around the outside of this, the perimeter itself is changing, and it's changing incredibly quickly. We're talking about applications running in the cloud, remote employees accessing those applications from anywhere, partners that want to have access to the internal network, mobile devices, bring your own devices. All of that is contributing to the ever-changing nature of the customer's perimeter.
So what you're telling me in short is that in order to be able to protect this environment, you need to find a way to protect those things, but you can't really touch those things. Is that what you're saying?
Yeah, I mean, I don't want someone putting something on my phone, but I still want to be able to access my critical business applications at whatever time that is convenient for me.
Okay, so you're saying that if I can't protect there, basically you have to find a way to protect somewhere here?
We can't even necessarily protect somewhere inside the old perimeter, because what about those applications that are out there in the cloud?
Oh, yeah, you're right, of course.
It's getting kind of complicated at this point.
Yeah, it's getting interesting.
In fact, it gets very interesting. Think about it like this. In the past, you used to have applications that would be sat there on a bare metal server in the data center. And that was reasonable enough. We could put a firewall in front of that bare metal server. And then virtualization technology came into play. We could start playing with virtualized firewalls or routing traffic to the physical firewall still, and we had a grip on it, and we could still maintain a similar security approach. But then the next shift happened, which is suddenly all the application developers wanted to put their applications in the cloud.
It's always the developers.
It's always the developers. I mean, what is the cloud? Who knows? But at the end of the day, this is where the applications are moving, and that becomes harder and harder to secure. It's very difficult to actually get a consistent set of application security controls applied in the cloud. But it doesn't stop there, as we know. What's going to come up next?
Come on, make me dream.
Containers.
The famous containers.
The famous containers. We've all heard about these containers. All the application developers can't get it off of their tongue. But the reality is containers do have a huge amount of benefits for those application developers that are deploying their applications. So it's presenting a new set of security problems that every organization is having to deal with. And we haven't even got to the right-hand side of this graph where we're talking about serverless functions.
I thought you were talking about Half-Life.
That does look like the Half-Life logo, but here we're talking about Lambdas, which, as you know, again, developers have many varied reasons to use those, and oftentimes they're very difficult to secure as well. So what a lot of organizations are looking at is changing applications requiring changing security needs.
I see.
And then exactly what do we think that needs to happen to change those security needs?
Yeah, to me, that seems like a very complex statement of what you're saying. So if I resume, you're saying this here is basically the physical premise, right?
Yes.
And then anything moving out over there is actually someone else's compute, in short.
Yeah, someone else's compute. I can't physically touch it. I can't put my firewall next to that unless it's virtualized, perhaps. But what do we do here? Who knows?
I see. So, what do we do?
Well, here's a couple of things that we think need to be put in place to start shifting the security. And really, we're talking about application-first security here, which is where rather than coming from the infrastructure up, we're applying security controls from the application down. So one of the core things that we need to be able to deal with is the fact that developers want to be able to run their application anywhere. What that means is any security product or any security controls that you're trying to apply for modern applications has to work in any type of environment.
So if you're saying that I have my banking system running on a mainframe somewhere in the middle of a highly secure data center, should be able to talk to a Lambda running in Amazon somewhere in the cloud.
Exactly. They all need to be treated as first-class citizens by whatever security tooling you are using. There is no way to decide that I'm going to have better security for my mainframes and worse security for my Lambdas. You have to have consistent security everywhere.
Okay. That seems like lots of glitters and unicorns right now, but
it does sound like a lot of unicorns right now, but I promise you, as we work through these sessions, we're going to explain exactly how we do this.
Okay, we need to.
We do need to. So then on top of being able to secure applications wherever they are running, we also need to be able to deal with this.
Change, this infamous change. So you're saying that basically those things move all the time?
They can pretty much be doing anything. They can be scaling up, they can be scaling down, they can be moving from one cloud to another. Application developers might be pushing out changes every time they commit some new code. There's a huge number of reasons why applications change. And it's actually very normal for applications to change. But what we found a lot of customers have got into is a state where they fear change. Change is bad for them because they have no way to deal with that change and no way to secure those changes at the speed that the business requires.
I see. So basically, a developer comes in, pushes something, and then someone else is going to throttle him and say, hey, wait a minute, security audit has to go through first.
Exactly. And you know what that ends up in?
Yeah, I can imagine that.
These kind of things.
Parking lot discussion. I
exactly. So the last thing that we want to do is trade off security for flexibility. We need to find that sweet spot where we can provide the application developers flexibility, but we can still provide that consistent level of security that the business requires.
Okay.
And then finally, what's the last thing that we think you really need to be able to deal with for this new world?
I'm waiting.
Well, it's uniqueness.
What do you mean? So you're saying that every customer has their own application?
Yeah. Well, we all like to consider that we are a special snowflake. I'm a millennial, so I definitely believe I'm a special snowflake.
Yeah, your hair, definitely, yes.
And the reality is, every application is special. There is no one application that is alike. Even when you deploy off-the-shelf applications like Active Directory, they can be configured in so many different ways that there is no one single way to say this is the template of what that application looks like.
So there's not a cookie-cutter solution for security today, basically?
Unfortunately, there really is no cookie-cutter solution.
Damn, I thought we could close the end early today.
It would be nice. We could definitely go home. But the reality is we have to deal with the fact that each application is unique, and therefore to secure those applications, we need to be able to deal with that uniqueness, but also deal with it in a scalable way. We can't be asking humans to look at each application and manually decide exactly what should be happening for that. It needs to be done in an automated, data-driven fashion.
Okay. How?
How? Well, we're going to get to that later. But exactly what might we want to do at a high level to secure those application workloads? Well, one of the first things that we think that you need to do really is begin containing lateral movement. If you think about that earlier statistic where it took 19 minutes for an attacker to get from the initial breach to a deep foothold in the customer network, one of the major reasons is because they were not applying any control on lateral movement inside the data center.
So you want to limit the bear from swimming around?
Pretty much. If the bear gets into my network, I want him to only be able to get access to the first thing that he can see, and then he will be locked in and can't get any further out.
That sounds a good idea on paper.
It does sound like a good idea on paper, right? Would you want a bear swimming around your network?
Yeah, the smell would be a problem.
Yeah, probably not. So we'll look a little bit later about exactly how we can deal with containing lateral movement when we don't have those traditional choke points that you would have in a data center that can sometimes be utilized to contain lateral movement. If I have an application in one cloud talking to an application in another cloud, I still need to be able to control that lateral movement between them.
Okay.
So we'll look in depth about exactly what that means to do that with Tetration. But we also want to look at exactly how we can begin to reduce those attack surfaces.
Okay, so you want me to remove the honey from the side of my data center, basically?
Exactly. One of the main reasons that that bear came looking for those data centers is because it was so easy to get that initial breach. Those web servers that are running unpatched old versions of code.
Never happens.
Yeah, never happens. Never happens, right? They are pretty much honey to a bear. And we want to be able to help customers reduce that attack surface, look for those vulnerabilities, lock down those applications, and do that in a way that works across all those different environments.
Okay.
So we're containing lateral movement, we need to reduce the attack surface, and then we also should be able to do this, which is track the compliance of our security rules.
Continuously track security compliance. Okay, you'll have to tell me what that means.
So think about it like this. If I put a speed limit on the road, but I don't put any cops out there with a radar gun checking the speed limit, what's going to happen? You know me.
Yeah, I mean, everyone will drive exactly at the right speed and not 1 mile above, right?
In a perfect world,
Okay.
right? But the reality is, if there's no one out there checking, things are going to start happening behind your back. And it's the same thing with your security infrastructure. You need to have that visibility and that way to track compliance to ensure exactly what you specify should be happening is happening.
I see.
And
so
again,
basically, trust no one.
trust no one, track everything they're doing, and make sure you have that tracking across all of your workloads across every cloud.
I see.
And then finally, we can pair that with the last piece of this triangle, or this pie, I should say, which is to identify behavior anomalies.
Behavior anomalies. So you're saying, like, if I take this door every single day and then tomorrow I decide to take this door, that's anomaly for you?
Exactly. Those kind of things, especially in a data center, we can begin to learn exactly what is the normal of an application. What does it typically do every day? Who does it speak to? What files does it access? What processes does it launch? Those kind of things are very, very easily picked up by machine learning, and then we can go ahead and work out exactly what the normal part of an application does. The reality is, even with containing lateral movement, reducing attack surface, and tracking compliance, it's still quite high chance that a customer might get breached. And what we want to be able to do is alert them within inside that 19 minutes that something different is happening on their workload than what used to happen.
Okay, I see. So in short, you're trying to slow them down.
Exactly. We might never be able to stop them, but if we can put as many roadblocks in place to slow them down and give us that time to react, we're all much less likely to be dealing with one of those front-page news stories.
I see.
And that's what we're going to be covering through this video series using Tetration.
All that?
All of that with one single product, containing lateral movement, reducing attack surface, tracking compliance, and detecting behavioral anomalies across any workload, across any cloud.
That's pretty impressive.
Yep.
So I'm curious to see how all that's going to pan out.
You know, it sounds like it might not be, or it might be too good to be true, but let's go through the rest of these sessions and exactly dive a little bit deeper into this. And we'll be looking at that in the next video in this series, exactly how we do this with Tetration at a high level.
Sounds good.
So with that, I thank you for joining me in this video. If you would like to get any more information on Tetration, please go to cisco.com/go/Tetration.